just under 4,000 kilometers. These needles are part of the West Ford project, which began in 1958 and were conducted by a scientist named Walter Morrow. Morrow and his team planned to place a belt of copper wires above the Earth to provide a fail-safe, and fail-safe communications system. The following video clarifies why these copper wires were launched into space. If you enjoy our videos, feel free to bounce off the small needles to the project. The West Ford project was a defense and communications project in space. Scientists hoped the mission would allow radio waves to bounce off the small needles, disrupting readings and boosting communications. Two major experiments were conducted, with over 500 million small wires launched into orbit using military satellites. The first experiment in 1961 failed, more on that later, and the second experiment in 1963 only worked for a short while. The wires dispersed as expected in the second attempt, but the transmission capacity diminished over time so that intelligible communication was possible only at the beginning of the mission. What were these copper wires needed for? Currently, radio waves are transmitted over long distances by reflecting off ionized gas layers in the Earth's atmosphere. Unfortunately, signals can be disrupted by the ionosphere, and events such as a large solar flare can cause radio fading by affecting the ionosphere's ability to do so. From a military perspective, radio fading or interference can be catastrophic in certain situations. Therefore, the Air Force supported Morrow's plan to create a fully reliable global communications system. In the 1950s, long-distance communications took place either by submarine cable or by radio, where electromagnetic waves reflected off the Earth's natural ionosphere. The United States feared that the then Soviet Union would sabotage these submarine cables, and this would have fatal consequences for the country. The copper dipoles had half the wavelength of 8 GHz frequencies for transmission. In the first project, the dipoles had a diameter of 25.4 micrometers, and in the second, 17.8 micrometers. The ring, which was mounted on the satellite, weighed about 40 kilograms. The copper wires accounted for half the weight, at about 20 kilograms. Many scientists and astrophysicists viewed the project with mixed feelings. If the project failed, then space debris would increase significantly. It would also potentially disrupt radio communications. What exactly happened? In October 1961, the first attempt was made to launch the copper wires into space to orbit the globe. However, the package used to distribute the copper needles in the required belt did not work properly. Of the original millions of needles, only a few ended up in space. It took more attempts to get the copper wires into space thereafter. The copper wires were mounted in a ring on an Air Force satellite and launched into orbit. Once in position, the ring was separated from the satellite. The blast spread the needles evenly around the satellite. This took almost a full day. At that point, the belt of copper wires was then 8 kilometers thick and 40 kilometers long. By comparison, today it is 1,600 and 18,000 kilometers. The second attempt in May 1965 was more successful. 120 to 215 million needles were placed in a sparsely concentrated belt around the Earth in a polar orbit. Within days, voice transmissions were successfully transmitted between California and Massachusetts. Initially, data was transmitted at a rate of about 20 kilobits per second, making voice transmissions difficult to understand. But as the needles continued to disperse, the transmission rate dropped significantly. 4 months later, the capacity of the transmission was only 100 bits per second. Why were no further attempts made? The rapid loss of transmission rate was one of the reasons why no further attempts were made. In 1965, these final attempts were set forth. Another reason for this was the progress in the field of communication satellites, so that the copper wires thus became obsolete. In the two trials, the copper wires did not release as the scientists had hoped. Large clumps formed, and the needles could not distribute themselves optimally. However, the second project was basically successful. The wires dispersed as they were designed to do. However, radio communication was only possible for a short time. The needles gradually scattered in orbit, and so the transmission capacity also diminished over time. So in the beginning it was successful, but scientists did not succeed in establishing permanent communication. Normally, more research projects would follow through with this mission. However, these had finished with the introduction of the remote communication system. This ensured better communication and replaced the small copper dipoles. Research was discontinued after that. What are the copper wires supposed to do? The copper wires are 1.7 centimeters long and 0.001 centimeters thick. There are then about 50 needles per 4 cubic kilometers. Despite the small size and low density of these wires, their ability to act as individual dipole antennas should allow signals of a certain frequency to bounce off. The Westford experiment was going according to plan, and the results of the wave propagation and actual communications experiments were quite good. If the project were successful, he said, the Air Force had planned to put 2 more communication belts into orbit. Science was ambivalent. The beginnings of the Westford project were controversial in the scientific community. Many opposed the grand experiment. Even the International Astronomical Union, IAU, rejected the project in 1961. Science was concerned with the issue primarily for 4 reasons. Number 1, observations of radio astronomers can be disturbed by copper wire. Astronomers admit that they cannot detect the needles today. However, they argue that the small dipoles will cause real interference if their observation equipment improves as much in the next decade as it has in the last. Although radio astronomers have the most to worry about, optical observers are also concerned. However, this hypothesis could not be substantiated either. Astrophysicists saw other spacecraft threatened by the needles. 2. Science criticizes behavior of the USA in space. The USA already has a bad international reputation for space missions because of the Starfish experiment. Project Starfish was one of the nuclear tests conducted in Iceland. A 1.4 megaton bomb was detonated at an altitude of 400 kilometers, injecting radiation into the Earth's magnetic field and creating an artificial Van Allen belt. This radiation did not disappear as US scientists had predicted. In fact, it rendered 3 satellites useless and seriously affected the work of radio astronomers. 3. A matter of national defense. Scientific projects conducted in the name of national defense are not subjected to the rigorous and open evaluation of other research projects. By being turned over to the Air Force, the Westford project became a matter of national defense rather than scientific research. Many scientists, especially those involved in the space program, fear that political and military interference will make criticism impossible. The damage is not to the experiment alone, but to the mindset that allows it to proceed without international agreement and safeguards. 4. More space debris. As many as 500 million needles were released into orbit in each ring. At the time, the Westford experiment produced a large quantity of mid-altitude space debris. In 2006, clumps of wire were still found, but the number has continued to decrease. What does it look like today? The project was eventually discontinued by a combination of the system's less-than-stellar performance and the rapid development of a more reliable, higher-capacity remote communication system, the Modern Communications Satellite. In 1962, Telstar, the first modern communications satellite, was launched. It transmitted television signals across the Atlantic for 2 hours a day. More than half a century later, clumps of copper needles still orbit the Earth far above, although most of them have fallen back to the Earth. Because they were so light, they did not burn up in the atmosphere. Many now lie under snow at the poles. In 2001, a report was published by the European Space Agency. This report dealt with the clumps of wire in space that are still floating around 40 years after the experiment. The difference between the wires, in more detail, was that the wire lumps would stay in orbit for several decades. The report proves that the planning of the rings for the satellites did not go properly. The payload could not distribute efficiently, and so clusters of needles formed. The Westford experiment fits into a time when the military and the research community worked together to plan and execute the first space missions.